All right, section 7.5, solving inequalities by multiplying and dividing. So we talked about when we solve inequalities, it's just like solving equations, right? Meaning if it's a variable times a number, we divide both sides. And that's going to be the same for multiplication and division. However, when we solve by multiplying or dividing by a negative, we're going to have a special rule. So our targets are to solve by multiplying, dividing by a positive, and solve by multiplying or dividing by a negative, right? And this is where our special rule is going to come into play. All right, so our key concept, and it'll make more sense. I know this is a lot of words right now, but we'll look at examples of them to hopefully help you out when you're doing this. It says when you solve using multiplication or division by a positive number, the inequality stays the same. Meaning if it starts with, right, let me give you an example, 3x is greater than 15, right? So notice to solve this, I have to divide by a positive 3. That means when I write my answer, the inequality does not change. It's going to still be the same. And we'll look at why that is in a minute. However, if you solve by using multiplication or division by a negative number, the inequality flips. Okay, and we'll look at why that is. So, important disclaimer here. The number you use to solve by multiplication or division determines if you flip the sign, not the result you get. For example, let's say that this was 3x greater than negative 15, right? So divide both sides by 3, and we get x negative 5. So my result, right, ended up being a negative because I divided a negative by a positive. However, notice I divided by this positive 3, so that's why my sign stays the same. So it doesn't matter the result, it matters what you use when solving, right? What you multiply or divide by. So let's look at some positive examples, right? And when we multiply or divide by a positive, um, our sign is going to stay the same. So in number 1, it says 8 times something is less than or equal to 40. So I'm going to start that by dividing both sides by 8, right? Because that equals 1x, right? So I get that by itself. Since I divided by a positive value, my sign stays the same. Whoa. So x is going to be less than or equal to 5. Okay. Number 2, d divided by 2 is greater than 7. So opposite of division is multiplication, right? And you think about it, something divided by 2 is 7. So that cancels there. We're left with d. Since I times by positive 2, my sign stays the same, and this becomes 14. Number 3, divide both sides by 5. So we have x here, and we would have negative 4.8 here. Now, this one is one where you have to be careful because you're like, oh, I got a negative. However, look at what we divided by. It was a positive 5, which means my sign will stay the same. Now, let's look at why we're going to flip, okay? So we looked at this in last lesson, and we'll start there just to relate it all together, right? Hopefully we can all agree that 5 is less than 10, okay? So if I add something to both sides, is 10 still less than 15? Yep. If I subtract the same thing from both sides, so we would have here 8. Is that going to be less than 13? And the answer is yes, right? So let's get this something that we want to work with here. Let's add the 2 back on there. So let's go back to that 10 is less than 15. Okay, and hopefully we can all um, agree with that. Now, if I divide, let's do this. Let's times both sides by 2 to start. Okay, times both sides by 2. So we would have 20. Is that less than 30? And the answer is yes. So if we multiply by a positive 2, it's going to be still a true statement, right? If I divide both sides by 2, right, and I'll bring it back over here, this would be 10 less than 15, right? So we can see that that's still a true statement. So if I added the same thing, true. Subtracted the same thing, true. Multiply by a positive, it's true. Divide by a positive, it's still true. However, let's divide both of these by -5. So when I do that, I get -2 less than -3. And let's think about that on a number line. Right, here's -1, 0, -2, -3. -2 is right here. It's right of 3, right? Remember, as we go from left to right, these values are getting larger. So this is not a true statement. So when we multiply or divide by a negative, that's why we have to flip the sign, or else it's no longer true, right? And we can, I'll show you a multiplication example. Let's times this by -10. Okay, times by -10. So this would give me +20. This would give me +30. So notice I multiplied by a negative. If I kept the sign the same, this is not true. 20 is not greater than 30. So anytime you multiply or divide by a negative, the sign has to flip. All right, so let's look at some examples. So here we have -2 times x, so I'm going to divide both sides by -2. Okay, now notice I divided by a negative value, so I have to remember that this flips, and this would be -4. Okay, it's not that my result's -4, it's that I divided by this -2 that caused my sign to flip. Right here, dividing by -4, so I'm going to times both sides by -4. So d, I multiplied by a negative, so I got to remember to flip. And this would be -20. Here, divide both sides by -5. So we get x. This is going to be +6.4. Okay, now don't be confused, right? You're like, oh, it's a positive result, so I must leave my sign. Say, no, remember, it's what you divide by. So I divided by this -5, that automatically flips my sign. Just because I got a positive result has nothing to do with flipping the sign. It's what you multiply or divide by that determines if you flip your sign. All right, writing inequalities. So number 1 gives me a story problem, and number 2, it gives me a graph. It says Bev earns $8 per hour in the summer working at an ice cream shop, right? So we should know that it's going to be $8 per hour. It says write an inequality to figure out how many hours she must work to earn at least $120. So at least, okay, let's think about what that means. At least means I want to earn 120 or more. Okay, so I want my income to be greater than or equal to $120, right? If I make 150, that's great, but at minimum is 120, and then more if possible, right? So anything more. And then in order to solve that, right, we could divide both sides by 8, and we would get h, right? Since I divided by a positive, value has to be greater than or equal to 15. And then writing from a graph. All right, so let's define a variable. Let's just say um, x. Okay, it doesn't matter. You could use a, b, c, but we'll pick x. I know it's not or equal to because that's an open circle. And as long as my variable's first, the arrow's pointing this way, right? And if I just pick a point, okay, what's the relationship between 6 and 8, right? Well, it's less than, right? So x has to be less than 8. All right, nice quick lesson today, right? Very similar to solving equations with one special rule, right? You flip the inequality if you multiply or divide by a negative. Okay, so your assignment for today is on page 353, doing number 14 to 34 even. Okay, now if you read the directions, it'll say solve and graph. Okay, we're only solving, okay, no graphing. You don't have to do the number line with the graph, just solve. So if your equation is x is greater than or equal to 5, okay, that's good. That's all you have to do. You don't have to do the number line where we say there's 5, right? We don't have to do that part of it. And then you're also doing 38, 44. And then practice these review problems. They are solving multi-step equations, right? Where if I have 2x plus 5 equals 15, right? We have to do 2 steps to solve, right? So I have to go minus 5. I'd get 2x and 10, right? And then divide by 2, and I'd get x equals 5. So it's multi-step equations uh, because that's going to be a preview for 7-6, okay, where we're doing the same thing but with inequalities. All right, so practice those, and then you can check your work when you're done. I hope you all have a great day, and we will talk to you soon.